The NKX is a centrifugal pump with a single mechanical seal specifically designed for hot oil circulation in industrial heating units. Unlike competitors' products, the integrated cooling and venting system works independently and permanently. There are no additional costs generated by the installation of cooling and venting devices or manpower required for the end user. This also means that there are no special requirements or burdens put on the operators during startup and operation of the pump. A major problem when handling thermal oil is cracking of the oil caused by high temperature. Low boiling hydrocarbon components collect as separated gas and ultimately solid coke around the rotating shaft and lead to premature failures of the mechanical seal. This film explains the function of this integrated cooling and venting system. The pumping grooves of the mechanical seal shaft sleeve generate pressure during operation and flush the venting device. The venting device separates the lighter gas and the liquid phase. The thermal oil enters the cooling coil while the gas is vented away from the mechanical seal. The cooler radiates the frictional heat of the mechanical seal to the atmosphere and reduces the thermal oil temperature around the mechanical seal. In order to reach a considerable temperature drop, a cooling fan is mounted to the pump shaft to guarantee sufficient air exchange. The cooling fan offers the additional benefit of cooling the bearings at the same time. The return port of the cooler is positioned at the seal faces of the mechanical seal and provides sufficient cooling of the seal. After passing the seal, the oil is picked up again by the pumping grooves and the continuous venting and cooling process starts again. The separated gas is vented at the upper path of the venting device through the pump bearing housing in a second area of the mechanical seal shaft sleeve. The sleeve is equipped with a pumping ring that continues the flow into the direction of the pump casing. At the end of the mechanical seal shaft sleeve, the gas is vented into the pump casing at the back side of the pump shaft sleeve bearing holder. The sleeve bearing holder is equipped with a top venting bore that releases the gas into the pump casing at the back side of the impeller. The normal pumping flow absorbs the gas and carries it out of the pump discharge. The interaction of these components forms the integrated and permanently working cooling and venting system designed to address primary seal failure modes in hot oil pumps. Once the suction and discharge valves are opened, the pump casing, mechanical seal chamber, cooler, and all other parts of the system will be filled with oil and partly vented. Opening of the suction valve is generally sufficient, provided that piping is level or sloping gradually downward from the liquid source to the pump inlet in order to avoid air pockets during filling the system. That also means systems with a check valve on the discharge side can be filled without separate venting of the discharge pipe. The time required for this filling and venting process depends on the viscosity of the thermal oil. The oil used for this film is Meatherm WU46. The viscosity of the oil is 43 square millimeters per second at 40 degrees Celsius. In this case, the time required is less than 3 minutes. If the viscosity is 4 times higher, or around 200 square millimeters per second, the filling and venting will take approximately 18 minutes. This venting time is not unique to the Dickow NKX pump type. It is generally applicable to all thermal oil pumps. A minimum filling time of 30 minutes is therefore recommended for viscosities up to 300 square millimeters per second. This viscosity covers almost all common thermal oils above 10 degrees Celsius. The start of the drive motor activates the cooling and venting system. The pumping grooves of the mechanical seal shaft sleeve rotate, generate pressure, and flush the venting device. The venting device separates the lighter gas and liquid phase. The separated gas is vented at the upper path of the venting device. The pumping ring leads the gas away towards the pump casing. At the end of the shaft sleeve, the gas is vented into the pump casing. The pumping flow absorbs the gas and carries it away. In order to have a better view of this process, the pump is operating with a reduced speed. The oil flows through the cooler and exits at the seal faces of the mechanical seal, crosses the seal chamber, and is picked up again by the pumping grooves and pushed into the venting device. The oil flows through the cooler and exits at the seal faces of the mechanical seal, crosses the seal chamber, and is picked up again by the pumping grooves and pushed into the venting device. The process repeats continuously and reduces the gas content. The cooling fan reduces the bearing temperature and guarantees sufficient air exchange for the cooler. In addition to the better reliability offered, this allows for higher gas content to be handled by this improved pump design. This is another major advantage of our NKX with cooling and venting system over other competitors' products. Despite the gas content, the mechanical seal will be constantly flushed with oil from the cooler. This avoids collection of gas around the mechanical seal faces. The venting time depends on the pump speed, viscosity, and gas volume in the mechanical seal chamber. Our example shows a gas content of 50% in the seal chamber at a speed of 2900 RPM. The system requires around 20 minutes to reduce the gas content to approximately 5% during this test. No increased temperature or dry running of the mechanical seal could be detected during this period. Thus, the system was effective in reducing two primary factors that can cause reduced seal life.